If you are asked to find the length of a line segment and that line segment is given to you on the coordinate plane, the easiest thing to do is to just draw in the missing sides of your right triangle, either below or above the line. It doesn't actually matter which way you draw the triangle because the side lengths will match. Notice if I find the side length of this vertical side on the right, 1, 2, 3, it's the same as the vertical side on the left, 1, 2, 3. The same thing will happen with our horizontal side. You'll notice it's a rectangle, so our side lengths will match anyway. So let's find what that is. 1, 2, 3, 4, 5, 6, and 7. All right, so now all we have to do is use the Pythagorean theorem, which remember is a squared plus b squared equals c squared. The a and the b are the legs, meaning the vertical and horizontal sides that make up my right angle. And the c squared is my diagonal. So I'm going to go ahead and label that right now, just to make sure. All right, so now we can plug these numbers into our formula. So I have 3 squared for A, 7 squared for B, and we do not know what c equals, so we must leave it as a variable. All right, 3 squared means 3 times 3, so that's going to equal 9. 7 squared is 7 times 7, 49. And then c squared, we don't know what it is, so we're going to keep it the same. My c squared is already isolated over here on the side, so that means that I'm going to go on this other side here. These are like terms, just going to combine them. 9 plus 49 is 58. All right. My last step is to get this c squared to isolate the c. So I need to undo the squaring. The opposite of squaring, remember, is square root, so we're going to do that to both sides. So I get c equals the square root of 58. Now, if you were trying to find the answer, and this is a multiple choice test, this is a possible answer. You could be done right now. But sometimes the tests will ask you to do additional steps. For example, they might want you to turn this into a decimal, either by approximating or by using a calculator. So let's look at how to approximate this as a decimal. So we know our answer is the square root of 58. In order to approximate, we need to find which are the perfect squares that are the closest to this number. Now I know that 7 times 7 is 49. So square root of 49 equals 7. I know that 58 is bigger than that, so we need to go the number above, which means 64 is 8 times 8, so the square root of 64 is 8. So I know that the square root of 58 must be between 7 and 8. So as a decimal, it's going to be 7 point something. So the easiest way to do this is to actually turn this into a fraction. So we're going to think of the distance from 7 to 8, this one whole. That's like our one whole is like a fraction bar. Okay? So we need to figure out how far is it from 49 to 58. How many pieces, how many square roots do we have in our one whole fraction bar? So from 49 to 58, the distance between those numbers, if I subtract, I would get 9. And that's the numerator of my fraction, because that's like how far I am between from 7 to 8. It's like, let's say there would be 9 square roots between 7, the whole number, and the square root of 58. All right, so then I need to figure out how many are in my one whole, how many pieces total, so I can have my fraction. So now from 7 to 8 is 49 to 64. So if I do 64 minus 49, 14 minus 9 is 5, 5 minus 4 is, so we got 15. So right now, if I were going to write this as a fraction, 7 and 9/15 would be a good approximation. But a lot of times you need to turn that into a decimal. So we're just going to divide that. Remember, this means 9 divided by 15. So the 9 will actually go inside of the division sign. Okay. So now 15 goes into 9, 0. 15 goes into 90. Now I know 2 15s makes 30. So there's 3 30s in 90 exactly, which means for every 30 there's 2 15s, so 0.6 will be my answer. So if I were going to approximate this decimal, I would say that the square root of 58 is approximately equal to 7.6.